In this video, we're going to look at the function f of x equals cos of x. Watch the previous two videos first. The previous two videos, we looked at f of x equals sine of x. Now, watch the previous two videos first in order for you to understand this video here. Now, in the previous two videos, we looked at f of x equals sine of x, and we imagined a circle of radius 1 here, and then and to understand sine of x here, we imagine there to be a point moving around the circumference of this circle here, and then as it moves around, theta increases, and sine theta represents the height as this point moves around. So if the point is here, this sine theta, if the point is here, sine theta represents the height of this point. Well, with cos theta or cos x, cos represents, hang on, if say the point is here, cos x represents this distance here, the horizontal distance. So if the point is here, hang on, if the point is here, draw yourself a right angle triangle here, and cos represents this distance here, and if when theta is 0, then this here is 1. So you see, cos will be this distance here. If cos happens to be, if theta happens to be around here, okay, then draw yourself a right angle here. So the right angle here is here. Well, 1 is this is positive 1. Well, from here to here is negative 1. Well, let's say the point is here, then this will be negative. Let's say, I'm going to make it up, negative 0.7, something like that. Okay, so from here, well, my point is that when we looked at sine of x, we looked at the height as it moves around. Sine of x represents a height. Now, cos of x represents the horizontal distance. So as it moves around, it represents the horizontal distance. Because, okay, let's look at this circle here. Let's move. I'm going to enlarge it to this. Now, you've got yourself a circle here. Hang on. So remember, the point here moves around this circle, around the circumference of this circle. Let's just say the point is here at the moment. Now, if you want to find out this length here, which we're going to call x. Now, x here, remember from our trigonometry, the c is here, the sun is here, and this will be cos. Okay, this here will be cos. This here will be sine. This here will be tan. Well, here we want to know x, and we've been given the hypotenuse, which is 1. So we must use cos. So in this case, cos the angle, which is theta here, equals x over 1. So this here neatly turns into x. You see, cos theta represents the distance here as it moves around. So cos theta represents this distance here. Suppose the point is here. Now, suppose the point is here. Again, we're gonna need cos. So here, cos theta equals this thing here, which is x over 1 again, and then this neatly turns into, well, this neatly turns into x. So x here represents cos theta. So if we want to understand cos theta as theta moves around here, if we want to understand cos theta, try to understand the width as it moves around. So you looking at cos theta is the same as you looking at this width as this width here as it moves around. So when cos, when you're looking at cos theta, you are looking at the width here from here to here. So suppose the point is here. then cos theta would represent, well, hang on, you would draw yourself a right angle here, a right angle triangle. Cos theta would represent this bit here. Okay, so similar to our previous two videos, cos theta in this case, let's say the angle here, let's say the point, let's say the point, hang on, let's say the point is here, which means the angle is 0 here. Well, when theta is 0, then cos of x represents, well, cos of x is 1, because the radius, remember remember that this here is 1, this here is negative 1. So when theta is 0, meaning that the point is here, cos theta will be 1, so it will be here. So yeah, cos theta will be here. When theta is 90, that means the point is here. You see, the width, yeah, the width here would be 0. So when the width here would be 0, let's say it's 45 here. You see, the cos here will be this distance here. My point is that, okay, when is that 180? So this here is 90, 180 is here. The width here, the width here is negative 1, negative 1. So this here will be negative 1. When it's back to here, it's 0, because cos theta represents the cos theta here represents this distance here. So when it's over here, cos theta would represent this distance here. So cos theta represents the width of this thing. Okay, so going back to here, let me start again here. When theta is 0, cos theta will be 1, so it will be here. When it's at 90, the width here is 0, so it will be here. When it's 180, it will be negative 1, because 1 is positive 1's here, negative 1's here. So when it's 180, it represents this distance from here to here, which is negative 1. That's why when it's 180, it's negative 1, so it'll be here. Okay, and when it's 270, which is here, the width here is 0, so 270 is 0, and when it's 360, which is all the way around here, it will be back to 1. So it will be back to here. So your function f of x equals cos of x will actually look something like this. Okay, and then in so in the sine, anyway, your cos theta, your function cos of x represents this. Well, I will elaborate more on it in the next video. But in short, when you look at sine of x, you're looking at the height as it moves around the circumference. When you're looking at cos of x, you're looking at the distance, this distance here, as this point moves around. So 1 minute, when it first starts, it would be here, and then as it moves around here, let's say it's here, then cos of x represents this distance here. Okay, I will elaborate more on it in the next video. Okay.